Hi everyone, and welcome to the Mat 211 review of random variables, discrete and continuous. So, we have a random variable x, which has the probability distribution table as shown. So we have x goes from 1 to 6, and we have various probabilities, 2 of which are labeled just A, so they're unknown. Now, those two probabilities are the probability that x equals 4 and the probability that x equals 6. And we're assuming that those equal each other since they're set to the same value. So we want to solve for A in the table. We want to determine the probability that x is greater than or equal to 3, and we want to determine the probability that x is less than 3. So let's go ahead and start doing this. First things first, let's go ahead and solve for A in our table. So we have that all of these probabilities need to sum to 1. So that means that 0.1 plus 0.1 plus 0.2 plus A plus 0.1 again, and then plus one more A has to equal 1. So now we can simplify this a little bit by, adding up all the values that we do know. So we've got 0.1 plus 0.1 plus 0.2 plus another 0.1. That's going to be 0.5. And we have two A's, so that's going to be plus 2A, 2 times A. And that equals 1. So now we can subtract 0.5 from both sides. That gives us 2A equals 0.5. So 1 minus 0.5 is 0.5. And then we can divide out our 2, which gives us A is equal to 0.25. So let's write that up here. A equals 0.25. So that's our first part of our problem. Next, we want to determine the probability that x is greater than or equal to 3. So let me erase my work here, make us some room. So now if x is greater than or equal to 3, then x can be 3, 4, 5, or 6. So when we know that x is greater than or equal to 3, we need to sum all of the probabilities that are equals. So what this means is that in our case, we're going to have the probability that x is greater than or equal to 3 is equal to the probability that x is equal to 3, since this is a greater than or equal to, plus the probability that x is 4 equal to 4, plus the probability that x is equal to 5, plus the probability that x is equal to 6. Now remember that A is equal to 0.25 for both of these, so we'll just fill that into our table. So we have that the probability that x is equal to 3 is 0.2, plus the probability that x is equal to 4, which is our A here, that's 0.25, plus the probability that x is equal to 5, well, that's 0.1, and then plus the probability that x is equal to 6, which is again 0.25. Now, if we sum all of these up, we find that this is equal to 0.8. So the probability that x is greater than or equal to 3 is 0.8. So we'll just write that in here, 0.8. Lastly, we want to find the probability that x is less than or equal to 3. So we'll start by calculating this directly, and then I'm going to show you a little trick. So first of all, let's consider the values that x could take that would satisfy x is less than or is less than 3, strictly less than 3. Well, we know that x could be 2 or x could be 1. And nothing else because we don't have any other values that are strictly less than 3. So therefore, the probability that x is less than 3 is the sum of the probability that x is equal to 2 plus the probability that x is equal to 1. Well, the probability that x is equal to 2 is 0.1. And the probability that x is equal to 1 is also 0.1. So that means that the probability that x is less than 3 is 0.2. Write that in here. Now notice that these two probabilities, x is greater than or equal to 3 and x is strictly less than 3, are summed to 1. So 0.8 plus 0.2 equals 1. The reason why this is true is that between these two probabilities, they cover our entire sample space. So the probability that x is greater than or equal to 3 is this part, and the probability that x is strictly less than 3 is this part. So therefore, rather than taking the sum of this, we could also do that the probability of x is strictly less than 3 equals 1 minus the probability that x is greater than or equal to 3. Because these two are kind of like opposites. And they cover the two parts of our total probability space here, which is 1. So notice that then this would be 1 minus 0.8, which would again give us our 0.2 that we were looking for. We could have also done this the other way around. If we had solved for the probability that x is less than 3 first, then the probability that x is greater than or equal to 3 would be equal to 1 minus the probability that x is strictly less than 3. So we could have done that too. So let me clean up my writing here, and I will, a is equal to 0.25. There we go. That's a little nicer to look at. So for our 3 answers, we have these 3 here, and that's the end of our problem. So before I go, I just want to remind you all that if you're looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our different resources. Additionally, if you're looking for tutoring services for your specific course, we have our tutor search tool, which you can find on our main website here, or by going directly to the tool at this full link here. So thanks so much and have a great rest of your day.